And welcome back. For this example, we're going to talk about limiting reaction, excess reactants, and what is percent yield. So to begin with, let's talk about what happens when we have two reactants with different units. So again, we can do stoichiometry and we can use what we know about converting from mass in liters into grams or liters of another substance. For this example, we're going to use sodium, which is a solid, and chlorine, which is a gas, and it's going to be making NaCl, which is table salt, which is a solid. In this example, we're going to make sure that we have our balanced equation. So we need a 2 here, a 1 here, and a 2 here in front of sodium. Let's say that I have 5.0 grams of sodium, and let's say I have 5.0 liters of Na or Cl, and I want to know how many grams of NaCl can be made. So we're going to go through the steps just like we did before yesterday to be able to determine which one is the limiting reactant, because the limiting reactant will be used up first before the other reactant, which means that the maximum amount of mass of NaCl that we can produce is based on the limiting reactant. So step number 1 is we're going to convert grams of Na to grams of NaCl. Remember, on our mole island map, this means that we are going to have to do 3-step process for converting. So we're going to always start with the number that we're given. So we have 5.0 grams of Na. We're going to get it out of grams of Na and into mole of Na. Then we need to get into mole of NaCl, which to cancel it out, Na needs to be below, and mole of NaCl needs to be above. Then we need to get out of mole of NaCl, and we need to get into grams of NaCl. So again, anytime we see mole over any other unit or under any other unit that is not mole, it is just going to be 1. Now when we look at the mole and mole, this means it's our mole ratio from our balanced equation. So the number in front of NaCl is 2. And the number in front of Na is also 2. The mass of Na is 22.99. All right, so we have 58.44 grams of NaCl. If we look at these end up being the same, so they really cancel out to be 1. Again, our units that cancel Na, grams of Na, mole of NaCl, leaving us in grams of NaCl, which is down in our bottom here. Since any time that we have times 1, it really doesn't need to reflect in here. So we have 5 times 58.44 divided by 22.99. And what we will get, our final answer is 12.71 grams of NaCl. That is for our first step. Now we need to do the same thing again for chlorine. So for this one, step number 2, we need to convert liters of Cl2 to grams of NaCl. So even though this is starting in liters, we still can use the 3-step process to convert from liters to moles to moles to moles to grams. And so we're going to start again with the number that we're given. So we're given 5.0 liters, and we need to get out of liters of Cl2. This is liters of Cl2 here. Go to moles of Cl2. Then we need to get out of moles of Cl2, and we need to get into mole of NaCl. Then we need to get out of mole of NaCl, and we need to get into grams of NaCl. So again, anytime we see mole that is with any other unit, it's just going to be 1. Our mole to mole ratio here, NaCl has a 2 in front of it, and chlorine has a 1 in front of it. Since this unit is liters, we must use the constant for gas at STP. So, of course, I didn't say that up front here, but we're going to assume that this is at STP, just so that way we are keeping constant. So this is going to be 22.4. So that's the constant. 1 mole is equal to 22.44. We've already calculated the mass of NaCl in the previous problem. That will remain the same at 80 or 58.44. Now, we can't divide this because this is not equal to 1. But we do know that our units of liters of chlorine have canceled, moles of chlorine have canceled, moles of NaCl have canceled, leaving us in grams of NaCl. So we're left with 5 times 2 times 58.44, and this is going to be divided by just 22.4. And of course, our unit up above is going to be grams of NaCl, because that still remains. So 5 times 2 times 58.44 equals 584.4. Divide this by 22.4, and our final answer is going to be 26.09 grams of NaCl. So when I look at these two answers, we can look at whichever is the smallest. 26 is significantly larger than 12.71. So this one here is the limiting reactant. And this one here is going to be the excess reactant, because we are going to have leftover chlorine because we cannot make 26.9 grams. Now we need to work backwards and find out how much excess do we have left over of our excess reactant, which is Cl2. Or we want to find out how much we should have used. So to find out how much we should have used, we can take our next step. So step 3 is convert the amount given of the limiting reactant and convert to the excess reactant. All right, so we were originally given 5.0 grams of Na. Now we need to convert out of grams of Na and go into mole of Na. Then we need to convert out of mole of Na and go into mole of the other reactant, which was Cl2. And since our original Cl2 was given to us in liters, we are going to get out of mole of Cl2 and go into liters of Cl2. Again, anytime mole is not with another unit other than, if it's with another unit other than mole, we will just place 1. Here is our mole to mole ratio. The mole value in front of Cl2 is 1, and the mole value in front of Na is 2. Our grams of Na were 22.99, and our liters, again, liters is a constant value at STP. This is 22.4 liters. So again, we can go ahead and simplify. We have 5 times 22.4 liters of Cl2 divided by 22.99 times 2. So remember, if you're doing this in your calculator, these numbers need to be reduced down first before you go ahead and hit the division bar. So 5 times 22.4 is going to give us, for our numerator, 112 liters of Cl2. And then our denominator, we're going to have 22.99 times 2. And so our denominator will be 45.98. Then we simplify, so 112 divided by 45.98 is the answer of 2.44 liters. So this is how much was needed of Cl2. Moving on to step number 4. Now what we need to do is subtract the given excess reactant we were given, whether it was volume or mass, and remove or take away what was actually needed. So this is what was actually used up in the reaction. So we have some chemical that is still left over that was not actually used. So our given value, that we started with was 5.0 liters of Cl2. And then we subtract away what we actually used or needed, which was 2.44 liters of Cl2. When we subtract these two away, this will tell us how much we actually should have used, so that way we would not have wasted any of the product. So 5 minus 2.44 would give us 2.56 liters of Cl2 excess. So this is excess remaining. So this is how much we did not need to use that was still there after the reaction was taken place.